Hello, everyone. This is Chandan Kumar from Anima Club, the aviation club of NIT Agartala. As we had started electronics playlist on our YouTube channel, so this is the second video of this playlist. In first video, you see the introductory part. In this video, we will discuss about the motors. Before discuss about the motors, let's discuss about the electronics. What is electronics? Electronics is a branch of science and engineering that deal with the study, design, and application of devices and systems involving the controlled flow of electrons through various materials. Its focus on circuit, devices, and systems that use electrical energy to perform a specific task, including processing, transmitting, and storing information. Now, go in depth of the electronics, we have to know some basic concept about basic electricals like voltage, current, resistance, power, and Ohm's law, and so on. So let's discuss these topics here. About voltage. The potential difference that derives current in a circuit is a voltage. It's measured in a volts. Current, the flow of electrons through a conductor is the current. It's measured in the ampere. Resistance is the opposition to flow of current and it's measured in ohms. This is the sign of ohms. The rate at which electrical energy is consumed or produced is called power and it's measured in watts and its formula to calculate power is equals to voltage into current. Now the Ohm's law. Ohm's law is the relation between the voltage, current and resistance. As we know, voltage is directly proportional to current and the proportionality constant we use is R, that is the resistance. So we get the formula V is equals to IR, voltage is equals to current into resistance. Now let's start our topics motor. As we see in RC plane and drones, we use motor and it is the essential components which is used because it generates thrust which allow our model RC plane or drones to fly. So in this video, we will detail discuss about what are the motor types we used, specification and selection criteria for the motors for our module. So what are the types of motors? Types of motors, brushed motors or brushless motors. Now let's see what is the brushed motors, what is the brushless motors. So first, brushed motors. The brushed motor is a electronic motor that uses mechanical commutation to transfer current to the motor winding by brushes and commutator. So in the brushed motor, we use brushes and commutator to transfer current using mechanical commutator. This brush and commutator used to transfer our current to the motor winding. Components of the brushed motor are rotor, that is that we also called armature, stator, and commutator and brushes. In this figure, we you can see this is winding commutator. Uh, this is the actual black one, and this red one is the brushes we use here. And so, what are the advantages of brushed motor? This is a cheap, simple, and easy to control. Now, what are the disadvantage? Because everything have some advantage, and along with it, it's have also some disadvantage. So, it's have low efficiency, wear out quickly, limited powers. What are the applications of brush motors? Small toy grade drones and entry level RC plane. We use brush motor. Now, see what is the brushless motor. We called it in short form BLDC. A brushless motor is an electric motor that uses electric electronic commutation instead of mechanical brushes and commutator. So in brushless motor, we don't have brushes and don't have commutator. Here we used electronic commutation. So it's have rotor, stator, and electronics speed control. Let's see here. In brushed motor, we have commutator and brushes. But in brushless motor, instead of brushes and commutator, we have electronic speed controller, or it's called in short form ESC, instead of brushes and commutator. Okay. In the figure, you can see here is no brushes or no commutator. Here we use ESC to control the motor operation. Now, what are the advantages of brushless motors? It's have high efficiency than brush motor, long life, more power. And what are the disadvantages? It's quite expensive, require ESC, electronic speed controller, instead of brushes and commutators. So that's why it's also expensive. What are the applications of brushless motor? Standard for most RC planes, drones, and racing quadcopters. It's mostly used in RC planes and drones instead of brushed motor. So let's compare brushed motor or brushless motor. Brushed motor have low cost, brushless have high cost. Brushed motor have low efficiency, brushless have higher efficiency. Brushed motor have limited lifespan, but brushless motor have a long-lasting life, as it's don't have brushes. Because brushes on the uses, it's get weird. Uh, it's simple to control brush motor, and require ESC to control brushless motor. And for beginners RC models, we use brush motors, and for high performance RC models or drones, we use brushless motors. So now let's see about the specification of motors. So for the specification, we have KV ratings, which means motor speed, motor dimension or size, voltage, its operating range. Motor operates in a range, uh, and current rating, power rating. So let's see KV rating or motor speed. It's describe the motor speed at no load. Its definition is RPM per volt applied. Low KV have high torque, large propellers, low speed, and it's used for mostly RC planes. High KV having low torque, small props, or high speed, so its uses in racing drones, as it have high speed. Here in this figure, you can see here mention 1000 kV. This is the kV rating. Now motor size. Generally, here in this picture, you see here is number 82212. This define the dimension of motors. The first two digit define the motor stator width in mm, and the last two digit define the motor stator height in mm. So here in this figure we have 2212, means 22 mm is the width of stator and 12 mm is the height of stator. Voltage, operating range. Motor have recommended voltage range often matching standard battery cell counts like 2s to 6s. 2s 6s means it's a cell count, battery cell counts. We will see it in our upcoming videos. So we have voltage range for operation of our motors, and current rating indicate how much current the motor can safely draw. Motor have a range for its safe draw. So an ESC that support higher amperes than the motor's maximum current draw. We have to choose a ESC which support the higher amps than the motor's maximum current draw for its safely draw. Power rating, as we know, power to calculate the power is a voltage into current. Higher voltage means more power, suitable for heavy or performance focused on models. So for the heavy performance, we use higher wattage motor. Now, selection of motors for RC planes. Uh, as the weight of the plane is more, heavier planes need more powerful motors. Propeller size, match motor kV to propeller size. As we have props, so we have to use lower kV motors, and if we have small props, use higher kV motors. Now battery voltage, ensure motor voltage range matches the battery voltage. As we see in the last slide, we have the voltage range for operating our motor safely. Power to weight ratio, M for 1000 per pound for basic RC planes and 150 watt plus per pound for aerobatic. We use this rating for this rating for our RC plane. We use 1000 watt per pound minimum, or for aerobatic we use 150 watt plus per pound. Uh, Now for the drones, uh, the the types of drones here: cinematic drones, racing drones. Cinematic drones use low kV motors for stability and longer flights, and racing drones uses high kV motors for speed and agility. As we have high kV motors, so we have high speed, and if we have low kV motors, so it's have a longer flights and stability. Now the frame size, motor size match the drone frame size. For 3 inches frame, then we have to use the motor of high kV, which having 1105 to 1407 range. If we have 5 inches frame, then we have to use mid high kV, which having 2205 to 2306. And for 6 inches frame, we have to use low kV motors, which having to 2507 plus. Now propeller size. Larger props need low kV motors for efficiency. As we see in the last slide, for low kV motors, we have to use larger prop to increase its efficiency. And if we use smaller props, then need we have need high kV motors for its speed to improve its speed. Larger, slower turning props require low kV motors for efficient thrust, as we need efficient thrust to good flight. So larger, slower turning props require low kV motors. Small fasting turn props requires best with high kV motors for speed, and ensure the propeller pitch matches the motor torque capacity. This is important. So this is the video about the motors. Thank you to be with the video. We will discuss more topics in our upcoming videos. So thank you.